Gravitational field strength. A field is a region where a particular property experiences a force. In a gravitational field, the property experiencing the force is mass. Gravitational field strength is defined as the force per unit mass, or per kilogram, acting on a mass placed at that point. So we can write gravitational field strength is equal to force divided by mass, or little g is equal to F over m. So the units of gravitational field strength are newtons per kilogram, or, as a force produces an acceleration, we can use meters per second squared. The two units are equivalent. Newton discovered that the force acting between two masses, big M and little m, a distance r apart, is directly proportional to the product of their masses and inversely proportional to the square of their separation, which we can write like this: force is directly proportional to big M little m over r squared. The constant of proportionality being the universal gravitational constant, capital G. And G has a value of 6.67 times 10 to the minus 11 Newton meters squared per kilogram squared. So we get Newton's universal law of gravitation, F is equal to minus G, big M little m, over r squared. The minus sign shows us that the force of gravity is always attractive, and so acts in the opposite direction to the displacement vector, from big M to little m, for instance. Newton's universal law of gravitation is covered in more detail on the video called Newton's Law of Gravitation. The Earth is not a perfect sphere, but is actually an oblate spheroid, as shown in this much exaggerated diagram, where you can see the polar radius is smaller than the equatorial radius. The mass of the Earth is 5.9736 times 10 to the 24 kilograms, and we know that force is equal to minus g big M little m over r squared, and also that little g, the gravitational field strength, is equal to the force over mass, which in this case will be equal to minus the gravitational constant times the big M, which we can take as the mass of the Earth, over the radius squared. So to find the gravitational field strength at the equator, which I'll call little g subscript e, we can write it equals minus the gravitational constant times the mass of the Earth over the equatorial radius squared, giving a value of 9.79 newtons per kilogram. The gravitational field strength at the poles, which I'll call little g subscript p, is the same calculation but with the polar radius squared, giving a polar gravitational field strength of a bigger 9.86 newtons per kilogram. Another unit for gravitational field strength is called the Gal, named after Galileo. This is used by geophysicists and is equal to 0.01 newtons per kilogram, making the value of G on Earth that we use in calculations 981 Gal.